I'm Marcus Smith, and this is Constant Wonder. Join us on our quest to find awe and wonder in all nature, human or wild, vast or small. A podcast in search of all that moves us beyond words. Your host for this episode is Tenery Taylor.
When Nathaniel Hawthorne, in the mid-1800s, reflected back on his first time seeing New Hampshire's Mount Washington up close, he had this to say: "Mountains are Earth's undecaying monuments. They must stand while she endures." Well, geologist Marcia Bjornerud has a more complicated take on the concept of terra firma.
I feel, as someone who studies the solid Earth primarily, I'm a structural geologist studying tectonics and mountain building and earthquakes. We're talking about the Earth all the time. It's clearly animate. It's moving. Rocks are moving around the globe. Mountains are growing. Rocks are crumpling and flowing over long time scales.
We live on a dynamic planet. In this episode, we'll explore some fascinating ways our Earth home regenerates itself. And we'll take time to consider that there are lessons in the rocks, and especially in their movements. Lessons for us humans if we'll just pay close enough attention. Marcia Bjornerud is the author of Turning to Stone, Discovering the Subtle Wisdom of Rocks. We began our conversation by talking about Wisconsin, where Marcia grew up, which was at one time oceanfront property.
500 million years ago, we were on the edge of ancient North America. Wisconsin and much of the rest of North America was at much lower latitude, too. So we were a tropical beach setting. There weren't any palm trees, though, because land plants hadn't emerged yet.
Those ancient tropical beaches over time hardened into sandstone, which was eventually eroded and dispersed by rivers and glaciers, creating a sandy soil.
So white pine is a major component of boreal forests in the Great Lakes region, and it's very happy on sandy soils that many other types of trees just don't thrive on. So the white pines really were the ones that got bigger than everything else and sort of shaded out all of the other trees. There were other species, but the really tall, old-growth, successful trees were the white pines. This is the big woods of Laura Ingalls Wilder. And it's hard to even imagine what those forests were like.
It's hard to imagine because a change came in the blink of an eye, in geologic time anyway. And it was humans who altered the landscape, and drastically.
In the 1870s and 80s, in the part of Wisconsin where I grew up, it was one of the richest parts of the country because of the huge amounts of money that were being generated by essentially deforestation of the great white pine forests. There are virtually no surviving photographs of the pre-deforestation times. We grew up with Wisconsin history books that were full of images of burly-looking men on sledges with giant lumber piles to be hauled out of the woods in the wintertime. Then once they were gone, they had sort of anchored the soil, and there was just nothing to stop rain and snow, meltwater coursing over the landscape and just really quickly diminishing soils that had been built up over thousands of years. And when you see photographs from the late 1800s and early 1900s of Wisconsin, it's just a denuded landscape that had ferocious erosion problems. The soil washed away. It made already marginal agricultural areas even more marginal. And by the time I was growing up in the 60s and 70s, there was widespread groundwater contamination, partly as a result of the thin soils being washed away and then having had to have lots of nitrate fertilizer put on them so that anything could grow, and tragic cases of babies dying shortly after birth because of blue baby syndrome, which comes from nitrates stealing essentially the hemoglobin from their blood.
The sad irony is that sandy soil anchored by the roots of massive pines, can hold water. Water that could have benefited agriculture had the logging companies left some of the giants standing. But with nothing to anchor sandy soil, it just washed away.
The land was just sort of worn out. The soil was diminished, the groundwater was contaminated, and the hilly nature of the area had always made it kind of a difficult place to have efficient agriculture.
Of course, this intersection of geology, economics, and culture wasn't yet forefront in young Marcia's mind. It was in retrospect that she realized the tragedy she'd witnessed growing up. As a child in this rural landscape, Marcia actually felt enveloped in a sense of mystery.
I grew up out in the country, very few companions around. I had just one younger sister, and we were just left on our own to wander around the property most of the time. And I do certainly recall picking up odd cobbles from a gravel pit that was on our property that, in retrospect, I now realize was a great outwash fan from the glaciers. And all of those cobbles each had their own stories. They'd been transported from northern Minnesota and even Ontario and jumbled together. So there was such a variety. But they were like a text that I couldn't read. Gray stones that had white lines, often intersecting in a way that looked to us like some sort of Chinese characters. This was a very distinctive rock type that we would find and puzzle over and sort of put in a jar and collect. But there were many others. There are the Lake Superior agates and old banded gneisses from probably Ontario, I realize now, and banded iron formation, blood red rocks that have their own fantastic story of oxygen first becoming abundant in the atmosphere.
So when you're in college and you're an undergraduate and you decide you're going to find out about the stories of these rocks, and you're on a field trip and you find yourself on the shores of Lake Superior and you gather up a few rocks that look very different from each other and you're very excited and show them to your professor, and then can you describe what the rocks look like and then what his reaction was?
So I do vividly remember this because it was an embarrassing incident. I'd picked up 4 or 5 rocks thinking they were all very distinctive and must have, really unusual origins. One was kind of a greenish, mossy color. Another had a gray matrix, but then almost like starburst orange crystals in it. Another was just almost like a brown Swiss cheese full of holes. And then another was one of these very distinctive rocks that I remembered from childhood, the gray rock with the white lines. And that one, I really wanted to know what it was. And I brought them to the professor. I was a very shy student. I was reluctant in classes to ever ask a question out loud, but I wanted to know what these were. And he looked at them quickly and said, "Oh, basalt. They're all basalt." And I do remember at that moment thinking, oh, how stupid of me. Basalt is actually the most common rock type on Earth. It lines the ocean floors. It's the black lava rock of Iceland and Hawaii. How could I possibly have missed that? And I include that anecdote in the book because part of my intent in using my own story as a kind of scaffolding for conveying geological ideas is to show the process of becoming a scientist and the way one struggles sometimes to develop an instinct for the natural world. And one of the challenges in geology is learning the basic vocabulary of the earth, which is rocks and minerals. It really does take practice, and just like learning a language, there are a lot of odd idioms and inconsistent spellings, exceptions to the rules that one has to get comfortable with. And that's what that anecdote sort of embodies.
But I can't blame you. If they are different colors, different textures, how could you think that they're the same? And so I want to ask this question. I'm wondering if this confusion could happen on any other planet that we know of.
That's a good question. Not to the same degree, because the look of rocks as we see them today depends so much on how long they've been lying exposed to oxygen at the surface, or whether they've encountered water in the subsurface or at the surface, or what other adventures they've had since they formed. And one of the really unique things about the Earth is just that there are so many different interacting entities that can create new kinds of rock, that can expose rocks that formed in one environment to some other conditions. There are just lots more things that could happen to rocks after they form that could change their outward guise and make it harder to recognize what they are. So there are both more rock types on Earth than any other rocky planet or moon that we know of, and there are more things that can happen to all those different types of rocks than on any other body we know of.
Throughout her book, Marcia Bjornerud continually drives home what a singular planet Earth is. And so I asked her why Earth is so different, especially because Mercury, Venus, Earth, and Mars, all the planets closest to the sun, they were all formed by the same processes and initially with similar mineral compositions, iron-nickel cores and silica-rich mantles.
I hope that perhaps some of the tech bros who are thinking about colonizing Mars might be listening in because actually all of the inner planets and moons started with the same raw materials, but only Earth, partly because it has water, also because life got started here, and because it has a very peculiar atmosphere, thanks to photosynthesizing life forms, it has invented out of the same raw materials many, many, many different minerals and rock types than are found on any other worlds that we know of in our solar system. So it's a combination of water, life, the peculiar atmosphere, and the ways in which all of these things interact with each other and with the solid Earth that has created such diversity.
Well, where does plate tectonics come into that formula?
Tectonics is really at the heart of that. It's a slow process relative, say, to the water cycle or the carbon cycle, but it's linked with both of those things primarily through the signature process of Earth's plate tectonic system, which is subduction. That is the recycling of ocean crust over timescales of something like 150 million years. So I know that seems like a really long time, but the Earth is 4.5 billion years old. And so 150 million years is just a tiny fraction of that. So on that kind of time scale, the floor of the ocean is recycled back into the interior of the Earth, the mantle. And as that ocean crust sinks down, it can cause terrible earthquakes in places like Japan and Indonesia and tsunamis. But it's an essential planetary rejuvenating process in that it connects the hydrosphere-atmosphere system with the solid Earth. So the slab, as it's going down into the mantle, carries a lot of water bound up physically and chemically in the rocks, and things like carbon dioxide too, and recharges the mantle. And it's estimated there's probably an ocean's worth of water in the mantle. It's kind of like a planetary bank account. And that water will come degassing slowly out of volcanoes. So plate tectonics is this remarkable way that the solid Earth itself recycles the crust and keeps the whole planet in communication, top to bottom.
You're talking about water being carried down into the mantle, and you're talking about the expulsion of gases and steam. It sounds like a breath cycle. It kind of reminds me of theories or beliefs from different cultures that maybe the Earth is alive, not just having living things on it, but being alive in and of itself. Thoughts on that idea?
Well, that's a complicated question and a dangerous one to some degree for scientists. Many people may remember the Gaia hypothesis of the 1970s and 80s, proposed by an atmospheric chemist named James Lovelock. The Gaia hypothesis posited that the Earth is in some sense a superorganism that has the capacity to control its own internal chemistry, sort of in the same way that we can maintain our blood chemistry and our body temperature. Lovelock proposed this actually when he was hired by NASA to design some sort of device that could detect whether there was life on Mars. And he started thinking about this, and he realized that he already knew the answer. There was no life on Mars. You just have to look at Mars's atmosphere. It's basically just volcano breath. Just the exhalations of volcanoes from its interior long ago. It's very thin atmosphere because it's lost most of it, but the mix of gases is just what you'd expect from volcanism. And they said, well, look at Earth's atmosphere in contrast. It's far from chemical equilibrium. It's got a weird mix of things like oxygen and methane that shouldn't coexist because they should react together and become carbon dioxide. The fact that they're in a state of disequilibrium is evidence there's something tinkering with the atmosphere, and namely that's life metabolizing and giving off different gases. So that got him thinking more about Earth than Mars, and he posited that in some sense, the Earth is alive, that it's respiring, it's metabolizing. But it didn't meet the definition that biologists had set up for a living thing. The Earth can't reproduce. And some biologists said that there's no organism we know of that cycles its own waste products. So it didn't meet the criteria for life that biologists had set up. And geologists were, I think, skeptical primarily because of the name. It may have been an unfortunate choice. Gaia, the goddess of Earth, had sort of new agey connotations. But in the 20 or 30 years since then, I think actually most geoscientists are Gaians, but we don't use that word. We call people who study Earth systems like this biogeochemists. They're looking at the physiology of the Earth. And I think in some sense, there's an understanding that if Earth isn't alive in a literal biological sense, surely it's on some complex spectrum. It's certainly not just inert matter. And I feel, as someone who studies the solid Earth primarily, I'm a structural geologist studying tectonics and mountain building and earthquakes. We're talking about the Earth all the time. It's clearly animate. It's moving. Rocks are moving around the globe. Mountains are growing. Rocks are crumpling and flowing over long time scales. So there's no question that things are moving. It's animate in that sense. Where I start getting into dangerous territory is it any kind of sentient planet? I don't know. I feel like I have interesting conversations with the Earth, but is it really talking to me?
Yeah, I want to know more about that because we started this conversation and you said as a child, I didn't know what the Earth was saying to me. And I think that's a beautiful thing to say. Is it just a metaphor for you? Let's just talk about Marcia.
I don't know. I feel that I can read parts of the Earth manuscript, let's say that, because of the way that I've been able to spend much of my adult life in rocky places far from the din of humans. Is the Earth speaking to me? I don't know. But I'm getting messages. And I did feel that as a child, that there was some kind of intelligence in nature. And I think I still believe that as an adult. We'd be fools to think that we're smarter than nature when this system of systems has kept itself going for billions of years. How could we possibly think that there's no intelligence there?
If the Earth has an intelligence about it, then there's likely something to learn from this stony planet whirling around the sun. When Constant Wonder continues, we'll hear some of the messages that Marcia Bjornerud received for herself in those rocky places far from the din of humans. I'm Tenery Taylor.
I'd like to take just a brief moment here to introduce you to another gem from the BYU Radio family of podcasts. It's called In Good Faith. You can immerse yourself in a soul-nourishing experience of spiritual exploration. Stephen Cat Perry is the host, and he features people of diverse religions and spiritualities. He always interviews them with an aim to come upon a genuine understanding of the guest's relationship with the divine. Maybe you're wanting to strengthen your own relationship, or maybe you just feel a hunger for thoughtful conversation that touches on faith and belief. Whatever your need, it's truly rare these days in the media landscape to find conversations that unfailingly nourish and uplift your soul. In Good Faith does that every time, and you'll find it wherever you get your podcasts. We now return to Constant Wonder.
Marcia Bjornerud is the author of Turning to Stone, Discovering the Subtle Wisdom of Rocks. She's also a professor of environmental studies and of geosciences at Lawrence University in Wisconsin. As part of her PhD research back in the 80s, she spent several summers camping out with just a couple of other researchers in a lonesome Arctic wilderness called Svalbard.
So Svalbard is an archipelago about halfway between northern Norway and the North Pole. We would typically be brought to the archipelago on a research ship run by the Norwegian Polar Institute, leaving from just north of the Arctic Circle and then taking a very slow trip on very high seas so that the vessel could do oceanographic measurements and then be dropped off either by helicopter or by rubber boat to a remote camp and basically not see anyone the rest of the summer. Or if we were lucky, maybe a helicopter would stop by with some fresh bread or something and mail. But it was very remote, and especially in the 1980s and 90s, before any kind of cell phone service. We had a radio that we could communicate with the ship that would continue to circle the archipelago slowly during the summer. But we were really had to take care of ourselves and just make sure we didn't get hurt or eaten by polar bears. So we learned to respect the weather and the terrain and each other.
How do you protect yourselves from polar bears?
Well, pay attention. Always scan the horizon. And we did have rifles and flare guns. So we just hoped for the best, that they had eaten something and weren't looking for geologists to snack on.
One of the greatest surprises she remembers is not polar bears discovering her camp, but some Europeans on a vacation of sorts.
This would have been in the mid to late 1980s, before the Iron Curtain had fallen and before the Polish Solidarność organization had proven successful.
Solidarność is the name of a Polish solidarity movement, a nonviolent effort on the part of citizens to overturn the authoritarian communist government. Their efforts led to a peaceful transfer of power in 1989.
So it was still Cold War days. And there had been for quite a long time a Polish research station some distance south of us. There was a big glacier separating us from that Polish research station. And many people in Poland in those days loved to go to Svalbard because it was actually a little breath of freedom in this very remote and relatively hostile place. So we were in our little camp. I think that year we had just 3 of us. And we, as usual, were scanning the horizon, checking for polar bears. And we spotted a group of really ragtag-looking people. We couldn't believe it, coming across the tundra. Where have these people come from on foot? And it turned out that they were a group of Polish plumbers and electricians who were, I guess, at the Polish research station fixing things up, and they were given a couple of days off, and they somehow made it across this crevassed glacier to the area where we were. They had known that there was a group of American students. And although we really didn't have a language in common, I had some German, very little Russian, they had a little English and a little French, and we somehow communicated, and they spent a day with us and stayed overnight, and we exchanged what little luxuries we had, chocolate and coffee and vodka. It was such a kind of primal experience of being a host in a way that we don't experience anymore, that we didn't know these people. They showed up. Of course, you must come and you must eat our food and you must stay with us. And we gave them better socks and whatever we could spare for their hard journey back. But it was such a heightened sense of being human. I can't recall any other experience that quite matches it. It just kind of awakened some really deep ancestral instinct that it's our duty to take care of each other.
The tundra of Svalbard magnified not only Marcia's connection with other people, it also amplified a sense of belonging to the earth itself. She explains it in her book as unselfing.
That's a phrase I've taken from Iris Murdoch, one of my favorite writers. And what I think she means, and I mean by that, is losing the ego, the constant narrative in your mind that tells you you are the center of things, and having your edges become sort of indistinct in the world with other people, the landscape, seeing oneself in proper proportion with respect to the natural world, especially understanding that it is so much more powerful, not in either a malign or benign way. It just is. And I think it's just that kind of clarity that the self is small and there's a much greater truth out there. So I feel very fortunate to have spent some sort of formative years of my young adult life in a place like that, where the place just had such gravitas. You had to conform to its way of doing things.
On a little lighter note, you have a lot of time on your hands in these places sometimes when you're not doing research and if the sun's not going down. But you and some colleagues came up with your own kind of outrageous radio code. I don't think it will ever replace the NATO alphabetic code. Tell me a little bit about that. And I especially want to land on the winning nomination for the letter P.
So yes, I mean, when you're in a remote place, there really is no entertainment other than what you can come up with. And so in Arctic Canada, I was part of the Polar Continental Shelf project that included perhaps a dozen different remote camps during the summers. And we would communicate with each other via radio each evening. And at some point, we came up with the idea of what could be the most confusing radio alphabet ever. Instead of Alpha, Bravo, Charlie, Delta, Echo, etc., words that would be easily misunderstood. So for G, K, and N, the word was new. GNU, KNEUW, and NEW. And for P, and we tried, if possible, also to think of words that had some geologic connection. And so the winning entry for P is a word that describes a lung disease that's caused by breathing volcanic ash. And that word is pneumono-ultramicroscopic silico-volcaniconiosis.
I love it. And how many years ago was that you came up with that and you could still remember it today?
I can still say it. I think it was probably, I hate to say even, it was 1990.
Geologic change can happen on a very slow time scale. Think continental drift, the erosion of canyons. But sometimes the Earth's surface is altered in an instant. In just a moment here on Constant Wonder, we'll hear Marcia Bjornerud tease out the geologic payoff from events that seem to human residents of the planet to be catastrophe. Bjornerud is the author of Turning to Stone, Discovering the Subtle Wisdom of Rocks. I'm Tenery Taylor.
I'd like to introduce you to another show from the BYU Radio family of podcasts, The Lisa Show, hosted by comedian, believer, and single mother Lisa Valentine Clark. The Lisa Show delves into most any challenge that meets us in the course of our lives, especially challenges in the realm of human relationships, whether it's parenting, mental health questions, or social issues. Lisa and her council of moms are willing to tackle it. Figuring life out is vexing enough without losing an ability to laugh or cry together or just plain talk things through. The Lisa Show. Listen wherever you get your podcasts. We now return to Constant Wonder.
The eruption of Mount St. Helens happened more than 40 years ago, and it's been possible in the ensuing decades to drive around the National Monument to see firsthand what's happened in that area since the 18th of May, 1980.
Of course, it was devastating to those who lived right around the mountain at the time that it happened. But it's been interesting to me as a geologist. I was in college when that happened. It's been interesting to see how the narrative about Mount St. Helens has changed in the last 40 or so years. Initially it was sort of seen as this proxy for a nuclear holocaust, almost, the gray ash blanketing everything. But it was surprising to scientists how quickly that landscape rebounded and how rich the vegetation became and how quickly that happened. It was an amazing laboratory to see how ecosystems reconfigure themselves. And of course, over the long time scale, volcanism is a very important way of rejuvenating landscapes. You think of, Italy and all the places that are in the shadow of great volcanoes. A large part of their productivity is thanks to devastating events like past eruptions of Vesuvius and Etna. This is just a fact about the Earth, and part of the reason that I write for ordinary Earthlings is to help people understand better how the planet works so that we can live more peaceably with it and not view these habits of the Earth as catastrophes. We just need to learn when to get out of the way and let Earth do what it does, and then when it's safe to go back again. And unfortunately, too many of our systems, especially property ownership, aren't really compatible with that way of living. We're very rigid about the way we use land and who owns land, but all of it belongs to the Earth, and the Earth is going to do what it's going to do. There are no catastrophes in the eyes of the Earth system. It's just catastrophes because of the way we put ourselves in harm's way.
Something like Mount St. Helens or Vesuvius, what does it do to the soil to have that kind of an eruption that we could look on with gratitude?
Well, volcanic ash is essentially glass, and it has all the constituents that would be in a magma. And most magmas, especially in settings like the Cascades, where they're subduction zones, are full of potassium and phosphorus. Phosphorus in particular is really a scarce element. It's often the limiting nutrient for organisms and plants as primary producers. And so when they get more of it, they're very happy. So it's taking elements that are often scarce in the surface environment and making them widely available.
You were talking about we need to get out of the way. And that's not to say that we can predict earthquakes, is it?
No, unfortunately. And this is close to my own work. I've seen the paradigm really shift in earthquake seismology from the 1980s, where there was great optimism that it might be possible to predict earthquakes in a real-time sort of way, that you could issue a warning like a tornado warning or a blizzard warning and everyone would get ready, to now saying, no, actually, even when a fault begins to slip, it doesn't know if it's going to become a great earthquake or just a modest one. And so I think the best strategy is to build infrastructure that is earthquake ready or proof, if possible. It should not be the case anywhere in the world anymore that tens or hundreds of thousands of people die in magnitude 7 earthquakes. As you get up into the 8 and certainly 9 realm, then it's very, very, very expensive to create structures that can withstand that kind of ground acceleration. But magnitude 6 or 7 earthquakes should not be devastating events, and yet tragically they still are in many parts of the world. So in that case, we just need to, again, be smarter Earth citizens, understand the probability of earthquakes of a particular size in a particular place, and then build accordingly.
There are also other forms of seismic change going on deep in the oceans. And we usually see the evidence of this type of transformative renewal, curiously, in the mountains. Let Marcia Bjornerud introduce you to turbidites.
So their name suggests their origin. I'll just tell you what they look like first, because they were actually known to geologists for probably 100 years before anybody knew how they formed. They're kind of stripy rocks. They're very repetitively layered sediments. They usually start with sort of sand at the base, and then they gradually fine upward into silt and then maybe shale over and over and over again in packets that are maybe a foot or less thick. And they never come as a single rock. They're always in swarms or herds. Turbidites are collectives. So people had noticed these in mountain belts all over the world. They're very common in mountains, but no one could really explain what their sedimentary origins were. And it wasn't until 1929 when an earthquake happened off the coast of Newfoundland and telegraph cables that had recently been laid were cut very quickly in succession, that it was recognized that something was moving really fast on the deep seafloor, and they knew exactly, where these cables had been and when they were cut. And so they could clock this mysterious entity moving across the seafloor at something like 60 or 70 miles per hour, and realized it must have been an avalanche of sediment coming off the continental shelf and then careening down as a slurry of turbid sediment that was this very powerful gravity flow, essentially. Now we call those turbidity currents, and the rocks that form them turbidites. And the only reason we ever see them is during collisions of continents. They're scooped up and thrust up onto continental crust, and we see them in high mountains. But no one has really ever witnessed in real time how they form. We can only kind of indirectly surmise that.
Turbidites, like volcanic blasts, are examples of fast changes in geologic time. From volcanic blasts blowing off the tops of mountains to continents colliding under the ocean floor.
I am constantly amazed and in awe of the creativity of the earth, the myriad things that Earth has invented that, again, just don't exist anywhere else. Life forms, of course, but just landscapes and different forms of ice, different kinds of rocks and minerals, and different opportunities for life in the many, many different niches that exist. I think that's the main mantra that I come back to. What a wonderfully creative planet this is. The natural world is so full of all kinds of metaphors for us. If we could only be more receptive to them, less narcissistic, both individually and collectively as humans. I think that more and more we're just turning inward and thinking that we have invented the world, and we forget that the stories of nature are way stranger and more varied than any plot lines of any literature that humans have ever invented. And there's a whole rich library out there for us.
One of those metaphors was driven home for Marcia during a really chaotic time in her personal life, a time when her life seemed to be shattering around her. It was during this very difficult year that she took some inspiration from granite. You'll remember that she grew up in Wisconsin, where soil was sandy, having eroded from sandstone. Well, that sandstone itself once lived in granite. And granite, as you know, is very hard. It's also found abundantly on Earth, but very rarely anywhere else in the solar system. And geologists have had many conflicting ideas over the years about how granite is formed. A recent theory, though, actually became a comfort and a source of wisdom for Marcia. Before we get to that story, we need to know, how is granite formed?
That's really one of the most persistent questions in all of geology. People may not realize this. Granite, we take it for granted. But the puzzle of how we ended up on Earth with so much granite has gone on for several centuries, actually. Here's the big idea. All rocks can trace their lineages originally to the mantle. To generate the crust, the mantle has melted. And you can generate basalt, the most common rock type on Earth, with essentially one partial melting step from the mantle. Unlike basalt, which has this short lifespan, after about 150 million years, it becomes cold and dense enough to sink back into the mantle through subduction. Granite can persist for billions of years.
And granite is the foundation for the continents, but it doesn't come straight from the mantle.
The latest thinking is that maybe impacts of space rocks early in Earth's history, we know that was going on the moon, thanks to the large craters on the moon. There's no reason to think Earth wasn't also struck then. It's just that it's erased records because of erosion and sedimentation. But impacts would be an efficient way of working water down into the crust, forming craters and fractures into which rain could penetrate and lower the melting temperature of basalt and could facilitate widespread melting or partial melting. And those partial melts would be enriched in the ingredients that you need to form granite. It's actually still an open question, and it's very fundamental because it has to do with how continents formed.
The pummeling of the Earth to create what Professor Bjornerud calls the granite planet, that theory was a source of inspiration to her back in the mid-1990s, when she moved from Ohio to take a post at Lawrence University. It's a small liberal arts college back in her native Wisconsin. Bjornerud hadn't been in her new position that long when she had one of the hardest periods of her life, when she herself felt pummeled by a cascading series of events. For starters, there were only 2 other geologists in her department, and after she'd been there just a couple of years, they both left the school within 1 year of each other. Not only that,
the building that the geology department was then housed in was due for demolition. And so at the very end of the academic year, I also had the immense physical challenge of moving the accumulated materials of the geology department from the past century.
We're talking literal tons of rocks.
Into temporary storage so that a new building could be constructed that we would eventually move back into.
All of this would have been simply frustrating, likely exhausting, but it was compounded by overwhelming stress in Marcia's personal life. See, one reason Marcia had decided to move back to Wisconsin was to try to heal a rift in her marriage. 7 years prior, she had married a fellow geologist at her college in Ohio, a man nearly 3 decades older than she.
About the same age, in fact, a little bit older than my parents.
Initially, they weren't concerned about the age difference, despite warnings from friends and family.
We were really close intellectual companions. And, the irony to me is that for 2 people who spent so much time thinking about deep time, we weren't really realistic about what time means at the human scale, that the age difference really was something to be taken seriously. We were of 2 different generations. Physically, our bodies were just on different time scales.
Socially, too. It was difficult to find friends who could relate to them, particularly when they started having children. They thought a new start in Wisconsin might help.
One of the advantages of that age gap, we thought, initially was that he could take early retirement. I could start in a new position back in Wisconsin, closer to my family, and he then would have time to take care of children.
This may have seemed like a tidy solution, but it didn't work out like they'd hoped.
The age difference between my husband and me became an insurmountable gap, and we were on the point of separating when he found that he had a very aggressive form of leukemia.
There was no acrimony behind the planned separation.
We continued to talk about geology and recent discoveries. So I found myself taking care not only of small children, but also of a sick husband. And then I discovered also that I was pregnant with a third son.
Imagine Marcia in this situation, the mother of 2 small boys, expecting another, picking up the slack at work when her team was reduced by 2/3, organizing a departmental move, and caring for a dying husband, whose leukemia, as it turned out, was a particularly acute form of the disease.
And because he was older, he wasn't really a candidate for a bone marrow transplant. So he had to have frequent blood transfusions, like every couple of weeks, and just became really too weak and exhausted all the time to really leave the house much. So it was more than a year of trying to care for him at home. Finally, he did have to go into hospice.
Marcia was only in her mid-30s, but she felt much older and terribly worn down. She did what she'd always done. She looked to the rocks for solace.
Being back in Wisconsin was a huge comfort, and being back on rocks that felt like home was actually part of that, as strange as that may seem. It really mattered to me that I was back on the old granitic crust again.
Consider the theory that granite was formed in such profusion here on Earth by meteorites, maybe even asteroids, raining down from space, speeding up the process of producing an exceptionally solid crust on planet Earth. The formation of granite became a comforting metaphor for Marcia as she found herself facing the future with 3 little boys, now bereft of their father.
The idea that cataclysm can in some way create something new and lasting and durable, I think is what I took from that. It's terrifying to contemplate the violence of those ancient events. And yet, look what came from that all this time later. And certainly as a mother, I hoped for my children that that terrible time in the end just brought us together and strengthened the foundations of our family.
The title of Marcia Bjornerud's book, Turning to Stone, it's just lovely wordplay. But it also captures what she's done again and again throughout her life. Remember that scene when Marcia was in college on the shores of Lake Superior? She was so embarrassed because she hadn't realized that her handful of totally different-looking rocks were all actually basalt. Well, she still visits that great lake and has quite a different experience now.
For me, Lake Superior is a place I return to again and again when the noise of the world becomes too overwhelming. The lake itself is so vast, you can't see the other side. But also the rocks that are gathered along its shores, transported there sometimes hundreds of kilometers by glacial ice during the Pleistocene, are of such a great variety. And they represent almost 2 billion years of time gathered together as if they're all in a great convention. And the way the waves cause them to rattle against each other is almost as if they're speaking to each other, sharing their memories across geologic time. And that sound of wave-washed cobbles and knowing the stories embedded in each of them and being able to partially read them, even if they're just tiny remnants of much grander manuscripts, always gives me this wonderful sense of connection and perspective that I think we all seek. I think it's healthy for all of us to be able to get up on a metaphorical high point and look down at our lives and see ourselves in miniature sometimes. Not to be reminded how small and insignificant our lives are, but to understand that we are just part of communities of many different types, both human and natural. Geoscience is very good at that, reminding us that in both time and space, we are small, but we are participants in these long-lived rituals.
Marcia Bjornerud is the author of Turning to Stone, Discovering the Subtle Wisdom of Rocks. and she's also a professor of geosciences and the Walter Schober Professor of Environmental Studies at Lawrence University. This episode was produced by me, Tenery Taylor, with help from Marcus Smith and Elaine Scott. Sound design was by James Call. Constant Wonder is a production of BYU Radio.